Welcome everyone. In this video lecture, we will solve a GATE 2025 EC question, which is a combination of full adder and X or gate combination based digital circuit. Okay, so the question is a full adder and XOR gate are used to design a digital circuit. Okay, with inputs X, Y, and Z. Okay, so basically a full adder and an XOR gate is used to design a digital circuit which is shown here. So one XOR gate in which we are giving input Y and Z and one input X that we are giving to a full adder circuit. Okay. The input Z is connected to the carry in. So Z is connected to the carry. So we are making this one as a carry in. Okay. Input to the full adder. So if the input Z is set to logic 1. Okay. So here the given when Z is set to logic 1. Okay. So here the Z is set to logic 1. Okay. So it is already given that we have to consider Z value equals to 1. Okay. So when Z is 1, okay, so then the circuit function as fill in the blanks with X, Y as inputs. So the options are an adder circuit, a substructure, a multiplier, and a binary to gray code converter. Out of any four, any one will be the answer. So that we have to identify. So first we have to look for the circuit, and there is a XOR gate. Okay, so in an XOR gate, okay, so first we have to think about the XOR gate. Okay, so in that XOR gate, one input is Y and one input is our simply Z, and Z is given 1. So that output will be what? Basically, as we know, Y XOR Z, or simply we can write Y XOR 1. Okay, so I'm just making what should be the output at this in. Okay, so I am saying this one is some output will come, like we can say like any output, say k, something k is coming. Okay, this one is nothing but simply I'm saying k. So what I'm writing, y and z plus 1, and this one is our thing. Okay, so y may be 0 or 1. Okay, y may be 0 and 1. Okay, and this one y may be 0 and 1, and z will be always 1. Okay, so z plus 1, z is 1. Okay, so better to write like this. Okay, y is this, and z is what? Z is, we have to consider 1. Okay, and this one is y plus z. Is it okay or no? Because z we have to take 1. So 0 1 is always 1, and 0. Okay, so we can say the y plus z is nothing but simply the y bar. If z equals to 1, the y plus z is nothing but simply our y bar. Okay, so k will be nothing but simply y complement. Is it okay or no? This one is the important point. Means y plus z will be y bar. Means here we can say that if the one of the input is high in a XOR. Okay, I am writing the statement. Means what we can say, if one of the input in an XOR gate is high, or logic 1 is high, or we can say the logic 1. Okay, XOR gate behaves like what? Not gate. Not gate. So there is a complement. Okay, so y plus 1, y plus 1, y may be anything, so it should be simply we can say y bar. Is it okay? Y plus 1 is nothing but simply y bar. Here we have already shown you y maybe 0 1, and z is 1. We have to consider 1. So 0 1 1, for the same input it is 0. So this one is a y, so it should be y bar. Okay, just the complement of this 0 1 1 0. Okay, so now this value is y bar and this one is simply our 1. Okay, so the function, so this one is a full adder circuit, so one can write the full adder function output will be x plus y bar plus 1. Is it okay? The full order operation will be just the sum of x plus y bar plus 1. So now next what we can write, x plus y bar can be written as 1s complement of excuse me 1s complement, sorry, 1s complement of y plus 1. We can write this one is 1s complement y. Okay, y is something like 0 1 0 1 anything, so y bar excuse me, sorry, 1 0 1 0. Okay, so just the 1s complement means just reversal. Okay, so 1 is complement of y plus 1, so it should be our x plus 1 is complement of y plus 1 is nothing but simply 2s complement of y, 2s complement of y. So we can say this should be our x plus, and 2s complement is nothing but simply we can say right like minus y, because why, because complements are used in digital circuit, okay, or digital computer for subtraction. Okay, so one statement, so this one is nothing but simply a subtractor, so because the 2s complement, the 2s complement are used in digital circuit or computers, also digital circuits, or we can sometimes say the computers, for simplifying simplifying the subtraction, simplifying the subtraction operation and for logic manipulation, and for logic manipulation. Okay, so this one is the x minus y. Okay, x minus y, because first we have written f x plus y bar plus 1, because this one is your y plus 1 logic high value, so this will give the y complement. Okay, so y complement, so y complement is 1 is complement of y. Okay, it's just the reverse of y, means 0 will be changed to 1, like that, plus 1, so 2s complement, so 2s complement y is nothing but simply minus y, so this is nothing but simply a x as a subtractor circuit. Okay, subtractor circuit. Okay. So this one is the question, very fundamental question, but it's a bit tricky. But this one is the, so this one is the answer for that particular question. Subtractor is the right option. Okay, right, correct option. Subtractor circuit. Okay. So this is all about this lecture. So thank you for watching this video. Thank you.